Hey guys, today we're going to practice the identifying variables and their correlation day 2 worksheet. So let's get started. So question number 1 asks, base your answer to the following questions on the graph below, which shows changes in the sun's magnetic activity and changes in the number of sunspots over a period of approximately 100 years. Sunspots are dark, cooler areas within the sun's photosphere that can be seen from Earth. So it looks like from the title, this is graph about solar sunspots and magnetic activity. I'm seeing year in the x-axis, and I'm seeing two different scales on my left and right side on the y-axis. One is for the number of sunspots, one is for the the magnetic activity scale, and I'm seeing two different lines, one for the sunspots and one for the magnetic activity. So 1A is asking, what is this graph about? To figure that out, find it in this paragraph right here. It says, the graph below, which shows changes in the sun's magnetic activity and changes in the number of sunspots over a period of approximately 100 years. And in case you don't know what sunspots are, it says sunspots are dark, cooler areas within the sun's photosphere, which is a layer of the sun that can be seen from Earth. So, what is this graph about? I'm going to summarize that and write the graph shows changes in the sun's magnetic activity and changes in the number of sunspots over a period of approximately 100 years. Next, what are sunspots? It tells you what the definition of sunspots are. So I'm going to write from my paragraph, sunspots are dark, cooler areas within the sun's photosphere. The sun's photosphere is a layer of the sun. Next, what is the independent variable or variables in this graph? So this is interesting because in this graph, we have more than one independent variable, and maybe we may have more than one independent variable or more than one dependent variable. So we have to look out for all of it. Let's first look at which our variables are. Remember, variables are just things that are changing within the graph. So the number of years are changing. That's a variable. The magnetic activity is changing. That's a variable. And the number of sunspots are changing. That's another variable on my graph. Okay, so which one is the independent variable? Which one is not changed because or impacted by the other variables? That would be the year. The time or the year is not affected by the magnetic activity or the number of sunspots. But the number of sunspot and the magnetic activity based on these lines look like they are affected by how much time is passing by or which part of the year they're in or which year they're in. So I'm going to say that my independent variable is year or time, whichever one you prefer to write. Next, what are the dependent variable or variables in this graph? So in this case, we have two dependent variables. The year is independent variable, so we're left with the magnetic activity variable and the number of sunspots variable. So both of those things look like they are affected or impacted by the years. They're changed by how much time is passing by. So my dependent variables would be the number of sunspots and the magnetic activity. Both of these are changing over time, and I'm seeing or trying to analyze whether there's a relationship or predicting or and seeing what's going on over time. So, E, what is the approximate number of sunspots in 1840? So, 1840, I should look at the year scale, my x axis, and 1840 is right here. To find the number of sunspots, I go upwards and I stop at the sunspots line that's labeled the sunspot line. I'm not going to look at the magnetic activity line because that's not what the question is asking for. So, here's 1840. I'm going to go up. I'm going to look towards the left to find my number of sunspots. If I was asked about the magnetic activity instead, I would go up to the sunspots and go towards the right to find the number for magnetic activity. So, kind of like this, I'm asked for sunspots, so I'm only looking at sunspots, and I'm also looking at the number of sunspot scale. I'm not asked about the magnetic activity. If I were to be asked about the magnetic activity, I would have gone up to the magnetic activity line and went towards the right to the magnetic activity scale to see how much magnetic activity is happening in 1840. So, what is the approximate number of sunspots in 1840? I'm going to go up, I'm going to go left. It looks like it's somewhere between 40 and 80. Just to be sure how much is each indent right here, increment, that's not labeled, I'm going to find the scale of this axis. So remember, the scale of axis from the previous video is higher value minus lower value divided by the number of jumps between values. So the scale for the number of sunspots, if I pick 40 and 0 to be my higher and lower value, it would be 40 minus 0 divided by 2 jumps, 1, 2. And that gives me 20 sunspots per increment. So that means this is 0, this is 20, this is 40, this must be around 60. So I'm going to say the number of sunspots in 1840 is around 60 sunspots. Next, F. Describe the relationship between the number of sunspots and magnetic activity. Now, to find the relationship, I'm going to look at both my line graphs that are made for the sunspots and the magnetic activity over time. And there can be more than one relationship between two different variables, not just one. So, first thing I'm noticing is let's look at these main different types of relationships that we talked about. Cyclic or cyclic relationships are when the graph shows a repeating pattern over time that has roughly the same increments between the ups and downs of that graph. So if I look over here, it looks like I have a peak for both my magnetic and sunspots close to 1840, and another peak close to 1850, and another one close to 1860, another one 1870, another one close to 1880, and then after 1890, after 1900, it's somewhat of a peak. And then 1910, I have somewhat of a peak, 1920 and 1930. So every roughly 10 years or so, I'm getting somewhat of a peak. You can also look at the troughs or the bottom parts and see if they match up to roughly the same amount of increments. You can also visually see what the spacing between each wave. So from this wave to this wave and this wave to this wave, it's roughly the same if you just eyeball it as well. And that tells you that this might be a cyclic relationship. There's another type of relationship that you might notice. Whenever the magnetic activity is going up, the sunspots are going up with it. Whenever it's going down, the sunspots are going down with it. That's a direct relationship. When direct relationships are when one variable increases, the other one also increases. And when one variable decreases, the other one also decreases. So they must also have a direct relationship, which means for my answer, I can say they both have a cyclic relationship as well as a direct relationship. It's more complex than just one type of relationship. And that's it.